Hi guys, I am Marilyn Alice Deliore. I will be explaining to you all how to catalyze affect rate of reaction. In order to understand how catalysts affect rate of reaction, it's useful to draw a reaction energy profile or potential energy diagram. On a reaction energy profile, the y-axis will be representing potential energy and the x-axis will be representing reaction progress on the extent of the reaction. And let's consider an exothermic reaction where the potential energy of the products will be lower than the potential energy of the reaction. You may remember that to break the bonds in the reactants, firstly, we must see an increase in potential energy in my system before forming bonds, and therefore a decrease in a potential energy. The height of the initial increase in potential energy required to break the bonds is known as the activation energy. If colliding reactant particles have less kinetic energy than the activation energy required, then no reaction will happen. So how does this relate to catalyst? Well, what a catalyst does, it is decreases the activation energy required. So as you can see, the blue line has a lower peak than the original black line, showing that there is a lower activation energy. There's a number of different ways the catalyst might do this, but for the IB, that's not important. So how does this affect the rate of reaction? Well, my catalyst has reduced the activation energy, therefore more particles colliding will have the required activation energy. So we will expect to see more successful collisions and a faster rate of reaction. As a quick summary of the key points, here a catalyst reduces the activation energy required in a given reaction, as shown on the diagram on the left, and if the activation energy has been reduced, more particles that are colliding will have the required energy for a successful collision. Therefore, the impact will be to speed up the rate of reaction.